Hello. Okay, good morning. Model class. Okay. 4 hours அதாவது ஒரே நாளில் நான் செய்யலை. இப்போ ஜூமில் செய்ய ஸ்டார்ட் பண்ணுற டைமில் நான் நெக்ஸ்ட் வீக் இல்லாட்டி அதுக்கு அந்த மாதிரி ஜூமில் செய்வேன். அந்த ஜூமில் செய்கிற கிளாஸில் நான் 4 hours கண்டினியூஸாக இது ஃபஸ்ட்டு செஞ்ச மாதிரி செய்யலை. பிகாஸ் உங்களுக்கு கஷ்டம் இல்லை. ஏன்னா இங்கே 4 hour ஃபோனை பார்த்துட்டு அதுக்கப்புறம் 4 hour ஃபோனை பார்க்குறது ஃபிசிக்ஸுக்கு ஃபோனை பார்த்துட்டு இருக்கிறதே கஷ்டம். ரைட்டா? ஓகே, அதனால் நான் அப்படி சொல்லலை. 2 hours தான் செய்ய போகிறேன். ஸோ இன்றைக்கு ஓகே 2 hours நடக்கும். வீடியோ போடுறதால இனி அது லைஃப் பிரச்சனை ஒன்றும் இல்லை. ரைட்டா? இந்த வீக்கும் அடுத்த வீக்கும் வீடியோ தான் போடுவேன். ரைட்டா? நான் சொல்கிறது அடுத்த வீக்கும் போக மாட்டேன். ரைட்? 2 hours தான் செய்வேன். அந்த ஒன்று சண்டே மார்னிங் வச்சுக்கோம், ஒரு 9 to 11 மாதிரி. அடுத்த கிளாஸை நான் அந்த அவங்களுக்கு டிஸ்கஸ் பண்ணிட்டு சொல்கிறேன். ரைட்? ஓகே, ஸோ இன்றைக்கி நான் ஸ்டார்ட் பண்ண போகிறது கெமிக்கல் கால்குலேஷன். ரைட்? அவனோட 3rd யூனிட். ரைட்டா? இந்த ரைட்டா? ஓகே, 3rd யூனிட் தான் இன்றைக்கி நான் ஸ்டார்ட் பண்ண போகிறேன். ரைட்டா? இன்றைக்கி 3rd யூனிட்ன்றது நம்மளாக ஃபுல்லாக அது ஒரு கால்குலேஷன் யூனிட் வந்து தான். ரைட்டா? நிறைய கால்குலேஷன் செய்யணும். ரைட்டா? பட் ஃபர்ஸ்ட் பார்ட் இது கால்குலேஷனில் ஃபர்ஸ்ட் பார்ட் தான் இந்த டியூப். இதுக்கு போகிறோம் இன்னொரு பார்ட் வந்து இது. ரைட்டா? நோட்ஸ் அவ்வளோதான். இதில் நோட்ஸ் பெருசாக இல்லை. ரைட்டா? கால்குலேஷன் தான் நிறைய. ரைட்டா? Okay, you should do a lot of calculations. There are many more questions you have to work out, right? Okay, so this is the first part of this chemical calculation, and another small part is another small part is left over, right? I'll give it later. End of this week, right? Okay. So first we should study valency and oxidation state, right? Valency and oxidation state. That's our first heading. Okay. So what's valency? Valency. I think I don't know about the term oxidation number, but valency is pretty sure. Right? You should have studied in O level, right? Okay, but however, we study that also, right? What's the meaning of valency? Valency is the number of electrons transferred during bonding, right? The number of electrons transferred during bonding is called valency, right? Oh, simply in another way, the number of bonds, right? The number of bonds an atom form, right? That's valency, right? And there are 2 types of valency: ionic valency and covalency, right? There's another name for ionic valency, that is electrovalency, right? Electrovalency plus covalency, right? Okay, so valency, there are 2 types of valency: electrovalency, covalency, right? So total valency of an atom is equal to electrovalency plus covalency, right? Electrovalency plus covalency. Okay, and what's electrovalency and what's covalency, right? Simply you can say what's valency actually? Simply the number of bonds, the number of total bond. Covalency means number of total covalent bond. Electrovalency means number of total electrovalent bond or ionic bond, right? Ionic bond. Electrovalency, or another name, ionic valency, right? Okay, that's the meaning of valency, right? Okay, so just take a simple example in NET class, right? What's the valency of this? Does it have any covalent bond around this? No covalent bond. So covalence is 0. Ionic bond. To see the number of ionic bond, what you have to do? Just see the just look for charges. If there are if there is one charge, one plus, what's the valency? 1. If there is one minus, what's the valency? 1. Right? Only the magnitude you have to consider. Magnitude. Right? 1. Oxide. What's the valency? What's the valency of oxide? O2 minus magnitude. Right? What's 2? Right? Mg2 plus. What's the valency? 3. There is no covalency, only electrovalency. Right? Okay. And NH3. What's the valency of nitrogen? What's the valency of nitrogen? 3. How many bonds are there? 1, 2, 3. Right? How many bonds? 1, 2, 3. So covalency is 3. And what's that covalency? Right? Covalency is 3. So what's the total valency? 3. Because there is no electrovalency. Right? Okay. Let's take another example. NH4 plus. NH4 plus. What's the valency of nitrogen? Nitrogen. What's the valency of nitrogen? Can anyone say? What's the valency of nitrogen? 5. Right? Valency of nitrogen is 5. Why? How many bonds totally? 4 covalent bond and 1 ionic bond. Right? Right? Charge is considered as ionic bond. Right? And the magnitude of charge is what? The number of ionic valency or electrovalency. Right? Charge number is just the number. Charge number is the ionic valency. Number of covalent bond is covalency. So total valency is what? 5. Total valency is 5. Okay. How many covalent bond? 4 covalent bond. How many ionic bond? 1 ionic bond. Ionic bond means what? Bond between cation and anion. There is only cation, but you know that there should be an anion. I didn't show that. Right? Ammonium chloride. So here there should be a chloride or nitrate or anything. So the attraction between this plus and minus is called what? Ionic bond. Right? So how many ionic bonds are here? Only 1 ionic bond, because 1 plus 1 minus. Right? Okay, got it? So this is the way to find valency, right? This is the way to find valency. So I think I hope you would have understood what's valency, right? This is what valency is, right? Okay. So again, valency is equal to electrovalency plus covalency. Okay. Any doubt? That's all about valency, right? And our next heading is oxidation state or oxidation number, right? Oxidation state or oxidation number. What's the meaning of oxidation state? Na plus. What's the oxidation state? Na plus. What's the oxidation state? Na atom. What's the oxidation state? Here the oxidation state or oxidation number is 0, and here it is plus 1. Right? Cl minus -1, oxide -2, nitride, the oxidation number is -3, right? -3. So what's oxidation state or oxidation number? What's the meaning? Okay, simply we can say, but this is not the deep meaning, real meaning, right? Just the simplified meaning, simplified definition, right? Okay, the oxidation state can be referred to as the number of charge, right? Oh, the charge number. Oh, simply the charge. Right? What's the charge of sodium atom? 0. So what's the oxidation state? 0. What? What's the oxidation state? Plus 1. Oxidation state -1, -2, -3. Right? So simply you can say the charge of an atom. Right? Right? Okay. But that definition is insufficient. Okay. Wait. HCl. Let's consider HCl. What's the valency of hydrogen and chlorine? What's the valency of hydrogen? What's the valency of hydrogen? 1. What's the valency of chlorine? 1. Okay. 1. And now, what's the oxidation state of hydrogen and chlorine? What's the oxidation state of hydrogen and chlorine? Is there any charge? No, it's a covalent bond. So there is no charge, right? So how to find the oxidation state? How to find the oxidation state? It's a covalent. Truly, it's a covalent compound, and it's also a covalent compound, right? Both bonds are covalent bond. So how to find the oxidation state? How to find the oxidation? Yeah, you should consider electronegativity, right? I hope you would have you have full, complete, perfect knowledge of electronegativity, right? Okay, we have started electronegativity in unit 1, and we have discussed electronegativity more and more in unit 2, right? So what's the oxidation state of hydrogen and chlorine? Oxidation state of hydrogen and chlorine. And here, what's the oxidation state of both hydrogen? First, consider this one, right? Okay, you should assume that this bond is 100% ionic bond, right? 100% ionic bond. That means this is not a covalent bond. One should be cation and one should be anion, right? Okay, that's the task. Which atom should be cation and which is anion? Yeah, most electronegative atom should be considered as anion because it will attract the electron pair, right? Which is the more electronegative? This is the electronegativity order, right? Which one? Chlorine is the most electronegative atom. So what it would do? It would attract the electron pair toward itself, right? Toward itself. So it will become H plus and Cl minus. This is this electron pair. H plus and Cl minus. Now tell what's the oxidation state? 1 plus 1 minus, right? Okay. Remember, valency has no charge. Right? You don't add plus or minus sign for valency. Just the number. Valency is just the number. What's valency? Number of bonds. Number of bonds. That's simply called valency. And what's oxidation state? Charge after the bonding. Right? Charge after the bonding. So you should definitely add plus or minus. Otherwise it's not oxidation state. right? Okay, so 1 plus 1 minus, this is the way. First of all, what's the first step to find the oxidation state? All covalent bonds should be considered as ionic bonds, right? All covalent bonds should be considered as ionic bond. Okay, that's not a problem. But which one should be plus and which one should be minus? It should be assumed based on electronegativity. This is the order, right? So this one should be minus and this one is plus. Okay, this is an assumption. This is not true, right? It's an assumption. It's a perfect total assumption. Totally, it's an assumption. It's not true, right? Actually, what's the charge on hydrogen and chlorine? Can anyone say? What's the charge on hydrogen and chlorine? Delta plus, delta minus. That's less than 1 plus, less than 1 minus. Delta plus, delta minus. But we assume the charges on hydrogen and chlorine are plus 1 and minus 1 respectively. Okay? Okay, that's all. And then, okay, this should be done. This thing should be done. What I mean? Converting this bond into this covalent bond into ionic bond. This should be done only for the bond between two different atoms. Only for the bond between two different atoms like this, hydrogen and chlorine, because both are different atoms and electronegativity of both are different, right? So if the bond is from same atom, that means this bond is called heteronuclear bond. Homonuclear bond. This is heteronuclear bond. Nucleus are different. Heteronuclear. For homonuclear bond, you can't do that, because there is no delta plus delta minus. If there is a delta plus delta minus only, you can do? Yeah, you can consider, you can assume that bond as an ionic bond. But here you can't do that. Electronegativity is same. Then you can do nothing. What's the oxidation state of these two? 0, 0. That's it. Right? 0, 0. So no. Right? Valency is 1. Valency is again what? Number of bond. What's the number of bond around this hydrogen? 1. What's the number of bond? 1. So valency is 1, but the oxidation state or oxidation number is 0. Right? Okay. Simple. That's all. Okay. And in your tute, take your hand out here. What's here? Total valency is equal to, okay, try this. Valency is equal to electrovalency plus covalency. Not